So we just got done with our warm up, right?
Yeah.
Oh, I guess I'm showing you the answers right now. So if you were paying attention, you would have saw all the answers up there, right? So how many of you were paying attention to that and saw all the answers? Lila, you saw all of them? Yeah. How'd you know?
Right.
Bread's here. Great. Okay. So we're working on the crust, right? So my first question to you is, what are our layers of the crust? So right now you should be getting these things written down. You need to get these 3 questions written down. What are our layers of the crust? Let's jot those down on the board here. You don't need to write them down because this should just be, right when I ask you that question, you should know all the layers of the earth. Right when I say, hey, what are the layers of the earth? You should be like, boom, they're this, and this. Cadence?
There's the crust.
Crust. Is the crust the innermost or the outermost layer? Cadence?
Outermost.
Outermost. So what comes after the crust? Lila?
Is it outer core? Or not outer, wait. Inner core?
New. Elijah?
Mantle.
Mantle. And then after the mantle is what, Lilia?
Outer core.
Outer core, and then outer core. And then Aaliyah, what's the innermost?
The inner core.
The inner core. Right, those are our 4 layers that we've been learning about over the last couple of weeks here. The crust, which is the outermost layer, the mantle, the outer core, and then we have the inner core.
Isn't there a lithosphere?
Yes, so we have the lithosphere and the asthenosphere, or the asthenosphere, however you want to pronounce it. Where do those 2 categories fall under? Do they fall under the crust, the mantle, or the core? You guys remember that, Aaliyah?
The mantle?
Yep, they fall into the mantle. Yep.
That's the core.
Yep, they fall into the mantle. No, the core is just the inner and the outer core. Okay, so with that said, list number 1 says list different types of landforms and what they look like. So landforms, who can tell me where landforms would fall under? Would they fall under the crust, the mantle, the outer core, or the inner core? Lila?
I would guess mantle.
No. Emmett?
Crust.
The crust, yep. All landforms are going to fall under the crust. So for number 1, let's jot down some different types of landforms. I'll jot that down. Actually, I'll jot it down on the board over here so maybe people online are able to see it. Who knows? Landforms. If you can't see this on the camera, yeah, you definitely can't see that. Landforms. Who can name a type of landform? Elijah?
Mountain.
Mountains. That's the first one I thought of as well. Mountains are one type of landform. What's another type? Max?
Like valleys.
Valleys.
Craters.
No, not craters. But yep, valleys. Aaliyah?
Rivers.
Rivers.
Streams. Or the ocean. Waterfalls.
No, those aren't going to be landforms. No. Lila? Geysers? No.
What about dirt?
Dirt? No. Emmett?
What?
Those are a part of landforms.
What about
Flat. So like, are you thinking of like the desert? So the desert, when I think of flat area, I think of the desert. So we have mountains, we have valleys, we have deserts. Man, there's a big one that we have a lot of around here. Oh, Lilia?
Hill.
Hills.
I didn't know if that was actually going to be right.
Yeah, that's good. What else, Lila? Meadows. Yep, I could write meadows up there. We could keep going on and on with landforms here, right? So right here, these are my 4 different types of landforms that I want you to know. So for number 1, this is what I want you to have down. Oh, rotate. So we have mountains, valleys, deserts, and hills. So get those written down from number 1. Okay, number 2. Max. Number 2, name the specific regions of the continental crust. Name the specific regions of the continental crust. Who can name the different regions of the continental crust? First off, we have the continental crust and the oceanic crust, right? Those are 2 types of crusty layers, right? No, man, you guys are my, yeah, there we go. You guys are my crusty class, right? Yeah. So what would be my specific regions of the continental crust, Elijah?
Antarctica.
No, it says in your reading. So when you guys read, because you guys read the lesson, right? Yeah. So when you read through the lesson, guess what? You read over what the specific regions of the continental crust is.
Apparently I missed it.
Leah?
The oceanic crust?
No.
The continental crust?
No, I'm asking for the regions of the continental crust. Emmett?
Is the Dead Sea?
No. Max? Go for it.
But it's like, it's made up of rock and granite.
It says in the reading in
That's,
143.
I know.
Go for it, Max. I'm still waiting on an answer from you.
Mount Everest.
No, we're not thinking of a place here. We're getting off the beaten path. It's not Antarctica. It's not Mount Everest. We are way off. Lilia? Nope, it's not a place. Not a place. Elijah, save us.
Shields.
Shields. Now we're getting closer. Okay, so I'm gonna leave that one for now. I'm gonna tell you here in just a sec. No. So number 3, fold belts are blank, forming young mountains. So this is a fill in the blank question from your reading. So
I know.
it says, literally, the sentence starts with fold belts are blank, and then it says forming young mountains. So go ahead and make sure you look through your reading, see if you can find it. I'll give everyone a minute here to look through.
My mind doesn't work.
I'm giving everyone a chance to find it first. Fold belts are blank, forming young mountains. All right, Aaliyah, did you find it? Hey-o. There it is. Oh.
Yeah. I seriously tectonic plates for some.
Folded rocks. Folded rocks. So, oh, yes, my chair is in the way. So, you already got number 1 written down. You don't need to write down everything that I have there. We wrote it down on the board already. So, number 2, I can't remember who, I think it was Elijah. You said shields? Yep, so shields, fold belts, and sedimentary basins. So those are the specific regions of the continental crust. You're going to need to know those 3: shields, fold belts, and sedimentary basins. For number 3, fold belts are folded rocks, and those help form mountains. So again, you don't need to write down number 1 up here. We already wrote that down here on our list up on the whiteboard over here. Yeah, so that's just describing mountains. So my question for you guys here is, what is the difference between mountains and deserts? What is the difference between mountains and deserts? I'm looking for one specific difference. Lila?
Sand.
Sand? So there is sand on mountains, so it's not sand, because you can find sand deposits on both. Emmett?
Thicker mountains.
Oh, so like the land mass is bigger? Okay, go ahead and rotate. Cadence?
Deserts are flat.
Deserts are flat. Okay. Yep, that is true. Not exactly what I'm looking for. Elijah?
Just a lot on the ground, so it's easy to go to the ground,
Not exactly. Not exactly, Lila.
Like in some deserts, you know, it's more
That's also true. That's also true. Aaliyah? Think about what's in mountains and what's in deserts.
In mountains, there's just sometimes lava in there.
Right? Yep, that's true. There is lava and magma within deserts as well, just not as much.
Yeah.
Yep. So what about thinking about what lives in the mountains, what lives in the deserts, right? So let's think of different breeds of cats and dogs, right? A cougar is going to live in the mountains or in the deserts? Mountains.
Well, birds can live anywhere.
Certain types of birds migrate all over the place, right? Thinking about a rattlesnake, are you going to find a rattlesnake in the mountains or in deserts? Deserts. A bear, are you going to find that in mountains or deserts? Mountains, right? So all of these different types of animals, they're going to be located in different regions, right? And why is that? Why are we going to find certain animals in certain climates rather than a different climate? Emmett?
Temperature.
Temperature is one big reason. Aaliyah?
Like naturally, like food, like sometimes the bears are little springs on mountains where they can get fish.
Right.
Just more berries and meat.
Yep. Yep. Bears, they need lots of food. In the desert, there's really not a lot of food. Yeah. Lila? Here's the next one you guys need to write down. Wally. Yeah, the pressure and the humidity. Yeah. So certain animals, they're just not going to be able to survive in certain areas, right? So as we spoke about with the bear, it needs more water. It needs to be around a lot of water. It eats a lot of fish, it eats a lot of berries, and those are only going to be found in the mountains, right? So those different landforms are made up of different types of materials. So how are mountains made? How are mountains made? Well, it's from the plates shifting, and that's what we're talking about right here. So plates are moving. Plates are going to be moving literally every second of the day. Now, how much do the plates shift every year? So it talked about when we talked about the mantle, how much does the mantle shift every year, Lila? Yeah, about 1 to 2 inches every year. Yep. So the mantle is going to shift 1 to 2 inches every single year. Lila, think fast.
What? I just solved this with one hand. How do you get it? Just
Solved it with one hand. Impressive.
milk.
So the hot mantle is heated by radioactive decay in the center of the Earth. Yes, I spelled center incorrectly. Yeah, I do that. So the hot mantle is heated by radioactive decay in the center of the Earth. So what does that mean right there? That the mantle is heated by radioactive decay. What is radioactive decay? We talked about this towards the beginning of the year when we were talking about carbon dating. What is radioactive decay, Max?
Well, you know how you said so it's white carbon-14 dating, but to go back farther, like billions of years, and you have
Yes.
to use radioactive stuff.
Yep, radioactive decay.
So it's
Right, so carbon-14 dating, we're only able to date certain living animals thousands of years back, right? With carbon-14 dating, you can't date anything back that is millions or billions of years old, according to, go ahead and rotate. according to old Earth theory, right? So radioactive dating is, in its name, it's very radioactive. It's very radioactive, meaning it's going to have a lot of reactions going on within it. So I wish I put a picture of that in here, but that's okay. So the heat that causes the liquid magma within the Earth to move is caused by convection currents. You guys remember what convection currents are? You guys remember what convection currents are, Max?
Is it like the chart is got like fluid and it measures how much is it the tectonic plates that we?
Not exactly. Emmett, do you remember what
I have the
convection currents are? Go ahead and read what convection currents are.
The circular movement of heated materials to a cooled area and cooled materials to a warmer area.
Yeah. So that image we showed the other day, that I showed you the other day, we have this little cycle going on. We had heat going up and cool air going down, and it was this cycle, right? Hot air going up, cool air going down. But then we had this happen.
But isn't it still
We have hot air still going up, but now cool air going down. So I'm pretty sure it was Audrey noticed that in this direction, it's going clockwise, right? We have a clockwise direction, but in this direction of the convection currents, which is during night, it's going counterclockwise. So heat's always going to be rising. Heat is always going to be rising because in the center of the Earth, it's the hottest. Inner core is the hottest. And as you get further and further out, inner core is the hottest, then it's the outer core, then it's the mantle, then it's the crust. And then you keep going further and further out. That's why they say the lower you are, the warmer you're going to be, and heat's rising, right? So that is all because of convection currents. And that's exactly how the plates are going to be shifting, is from convection currents. So what's another way plates can move? We talked about it yesterday. There's one specific term that I'm looking for. What were we talking about yesterday, Aaliyah?
I don't remember, but it's just when the earthquakes and just when the neutral or move, like
Right.
Move.
Yep, the plates are sliding. Yep. What was that word, Emmett? Like a what? Slide? It has to do with sliding. Yep. Because when we were talking about, I'm not going to give too much more away. Lilia? Subduction. Subduction. That is what I was looking for there. Subduction. So subduction currents. Subduction currents are when we have the oceanic crust going underneath the continental crust, right? Because the oceanic crust is less dense, so it's going to go underneath that that crust layer. So it is these huge convection currents which causes the plates to move. So right here, this is one reason that plates are going to move, is from convection currents, from radioactive decay. That right there, those are two different ways that you're going to see plates moving. The other way is what we talked about yesterday. Okay, any questions here? Guys ready to move on to the next one? Okay, when do plates move? So we know the why, but what about the when? So plates are going to move when there is a crack. So make sure you get this written down. I'm going to draw another image up here on the board. Some of you might have saw it when you walked in, because I didn't get to erase it in time. So I've used this example many times, but I worked on putting in my driveway over the summer. And when I put in my driveway, I had the big old cement truck come in, and I had them pour it in the area that I dug out, right? And in that area, once they poured it in, I used like this big broom looking thing that spread all that concrete out to make it all smooth. Go ahead and rotate, and this will be the last time we rotate. So when I used that broom to move it all around, I had it all nice and flat. I smoothed it out, but I had to do something next. I had to add these little cracks, and you'll see this when you are walking on a sidewalk or on a freeway or on a, right? We have all these built-in cracks right here, right? Right? So why are those cracks built into any concrete path, asphalt path? Why are those there? Why don't we just pour in a big concrete slab and leave it like that? Right? Why do we pour it like this and put in those cracks rather than pouring it in just one big rectangle? Cadence?
Because like earthquakes.
You have an earthquake, it'll crack. True. If you have an earthquake, it'll crack. Both of them would crack, right? I mean,
because the plates shift and they want to crack right there so that it doesn't crack everywhere else and just stays a concrete.
right. So hopefully you'll get it to crack right on that crack line, right? But what happens if it doesn't? What if for some reason there's a big rock and it's dropped right here and all of a sudden we have a crack, right? So there's my crack, that little zigzag line. So what happens when that crack keeps on expanding? It's going to eventually stop, right? It's going to stop at that line that we created. If I did the same thing here, what's going to happen to this crack? It's going to keep going and going and going, right? Which crack is bigger, this one or that one? Number one or number two?
One.
Number one is much, much bigger, right? So so Mr. Newmer, why are we talking about concrete and sidewalks? Well, when the plates move, we have our, what's it called? Our plates, right? Our different tectonic plates, there we go. We have our different tectonic plates. So our Earth is not built like this, just one sheet of concrete. That's not how the Earth is built. The Earth is made with a bunch of different sections, right? We have I've shown you in a couple of different maps throughout the year, how the Earth is made up within the different sections using plates, right? So when you have one earthquake, it's not going to go all the way across the world because there's different tectonic plates. Now, there could be a reading all the way across the Earth, right? But that's not the same as there being an actual earthquake. So when plates move apart, a crack appears between them. That's exactly what Emmett was saying with what we're trying to do with those different in between the sidewalk. We're trying to cause the crack to occur in there rather than on the actual concrete or asphalt. So molten magma flows from the mantle into the crack. So in the mantle, it's going to come up, the magma is going to come up in through that crack and keep on traveling through that crack. And once that crack is there, can it be filled in? Yes, it can. But over time, that crack can keep on getting bigger and bigger and bigger and keep on moving, right? So this is seen as volcanic activity. Yes, Lila? A dirt cycle? Oh, a dirt sidewalk? Then it's totally different. It's not hard. So with concrete and asphalt, it's really hard. So it's going to crack, but with a dirt, pretty much every type of dirt path or like a gravel path, it has more give. It's got some air pockets in between. So it's going to be more willing to move.
Basically, like gravel.
Right. Yep. Yeah. Any questions here with when they are going to move apart? Make sense so far? Yeah. One yes and everyone else quiet. So that means one person understands it. Good.
Yeah. 3.
Oh, good.
Oh, Emmett, I meant to throw this at you.
Oh, yeah.
I really got me so anxious that.
You stole your answer. Okay, on to the next one. We're almost done, guys. Almost done. We got 2 more slides. Let's get through it. So when plates move apart, so continuing on from the last one. So most of this volcanic activity occurs hidden from the view in the depths of the ocean. So a lot of the actual activity, a lot of the earthquakes are actually happening not on the continental crust, rather they're happening in the oceanic crust. So a lot of the earthquakes and movement is happening in the oceans rather than the actual continental crust, which is land, right? Max, you getting this written down? I mean, I already knew the answer to the question. Kind of rhetorical. You guys read that red okay? Kinda.
You know what color it was?
I did, because the other class told me.
Oh,
He's
boy.
showing you.
Wait, so that's green for you, right? That's
It looks like red now that I know.
Have it in your brain and
My brain is smart. It's able to tell me what certain things are. So
you're like Mega God mode gives him power.
yeah.
That's new form. God.
Okay. Last one. You guys ready for it?
No.
No? Okay.
30 seconds. I will be.
I'll give you 20.
25.
25, you got it. What's the deal?
I am 19. I got held back a long time.
Okay.
Yeah.
Max, if I were to look at your paper, did you get this written down? Come show me then. Bet.
Yeah.
All right, there's your 30 seconds. When plates come together, so we talked about how they go apart. Here is how they come together. Obviously,
We need to draw this down.
you don't need to draw that, but you need to write that. It's actually not that hard of a picture to draw in reality.
So, do we need to
Okay,
write
here you go, Max.
on the picture?
No.
No, you don't need to, no.
Oh.
So we talked about the plates going away from each other and how that causes there to be cracks. But what happens when they collide, when they come together? So this is where we were talking yesterday about, what was that word? That
Subduction.
Lilia said, yep, subduction. The subduction. So looking right here, we have our oceanic crust. And what is happening to it? It's going down. It's going down. And where does it stop? It stops in the mantle. So it's going to keep on going down until it gets into the mantle, the continental crust. It stops right when you get to the ocean right there, right? So what's happening right here, where the oceanic crust is colliding with the continental crust and it's colliding with the lithosphere and colliding with the asthenosphere, what's happening is, see all these sediments right here? There's a bunch of sediments that are going to start to rise and go push up and form little mountains, right? And form little mountains or little hills. What also is going to happen is there could be some type of movement that is caused, right? Or tsunami. And then there's also could be some, so if there's some kind of crack that ends up occurring, there could be some magma that goes up into that crack. And if there's any kind of earthquake, that's where that crack can become bigger, much quicker, and cause those to react. So when two plates collide, one will be forced beneath the other. So which plate is forced underneath which? Which one's going to be below? Which one's going to be on top? Elijah?
Top and the oceanic will be on the bottom.
Yep. Continental crust will be on top. Oceanic crust will be underneath. Good. So usually the more dense oceanic crust, or sorry, the less, wait, it does say denser.
It goes down.
Interesting. Usually the denser oceanic crust is forced under the less dense continental crust. All right, so once you guys get this slide all written down, you can start getting all cleaned up and quietly, you may head out to your next class. So we're not done with this lesson yet. We will finish it up tomorrow in class. Those of you online, later. Everyone say goodbye to online.
Bye.